Hello, everybody. Um, Unbelievable, we are here at the last keynote of the conference. It is an honor and a pleasure to me to introduce our closing keynote speaker, Mine Dogucu. Mine is an assistant professor of teaching in the Department of Statistics at the University of California Irvine and an incoming lecturer in the Department of Statistical Science at University of College London. She is an educator with an interest in statistics and data science education and an applied statistician with experience in educational research. She works toward the goal of making statistics and data science physically and cognitively accessible. She enjoys teaching art and teaching with art. She is the co-author of the book Bayesrules, an introduction to Applied Bayesian Modeling, and the accompanying art package bayesrules. She will deliver the talk Teaching Accessible and Teaching Accessibility. Mine, thank you so much for being here, and the stage is all yours.
Thank you for the introduction, Shani. It's really good to be here because I attended my first user actually last year, and I was very honored to be invited for a keynote this year, only after 1 year. And during my talk, you might sometimes see me move my arm. That's mainly because I'm in my office and my lights are automatically turning off if they don't recognize me. So that's why I would be moving my arm. And let me share my screen and get started. All right, so I will be talking about teaching accessibly and teaching accessibility. But before I do that, I want to mention that I will talk about my own teaching context, but for many of us here, we don't necessarily be teaching in a classroom. Many of our members of our community, they actually teach through other venues, such as workshops, blog posts, social media posts. We do teach each other in other contexts, not necessarily in a classroom. The examples I will give will be from my own teaching classroom, teaching at a university setting, but the things I will talk about can be extended to teaching anywhere, even sometimes just teaching our colleagues through a conversation. So the context I teach at the University of California Irvine, as Shani mentioned, and this is my third year here. I've been teaching many courses in the statistics department, some of them more on the statistics side, some of them more on the data science side, and some computing courses as well. And the important thing I want to mention about my teaching context is in our department, even though I'm in a statistics department, I'm actually in a school of computing. So we are housed with the informatics department and computer science department. And we do not have an undergraduate degree in statistics, but we do have an undergraduate degree in data science. And this will become relevant very soon in my talk. And I teach in all my courses, I teach most of it R. I do teach some courses where R is just a tool. It's used like a calculator. The focus is actually on the statistics concept. And I do teach courses that are actually more where I'm actually trying to teach R. So, for instance, I teach a course called Scientific Computing with R. I'm trying to teach the computing aspects of R in that case. I will talk, I have divided my talk into 3 parts. I will first talk about teaching accessibly, and then I'll move on to talking teaching accessibility. And then I'll go ahead and try to give some recommendations for the community. So, in the first part of the talk, I will focus on teaching accessibly. And in this part, what I'm trying to mention is how do we make our teaching materials, teaching resources that are accessible to all learners. That's our goal. And in this part of the talk, I'm going to talk about my collaboration with Alicia Johnson and Miles Ott. Alicia is at McAllister and Miles at Twitter. And I have also provided links to their social media accounts. I I've been collaborating with them and learned so much, and would like to acknowledge their contribution to my own career and development as well. And I forgot to mention one thing, for those of you who are following slides, Chen has posted them. If anybody is using screen reader, you can actually hear a sound as I switch the slides. I'm currently on slide number 5. I should have mentioned that earlier. Sorry about that. So Alicia, Miles, and I got together to write a book on Bayesian statistics. But before we started talking about the content of the book, we set ourselves one goal. And we wanted that book to be accessible and inclusive. Unfortunately, none of us were trained on accessibility or inclusion in our academic training. So we did not necessarily have a list of resources we could directly go to and be like, okay, if we do this, our book will be accessible. There was no resource like that. So we were trying to define what it means to write an accessible book in terms of what we knew, and we went ahead and researched. So this is, I'll talk about some of the criteria that we have developed for a book that is supported with what it's meant to be accessible for us. So for anybody who would like to read the book, I'm not going to talk about the Bayesian content of the book, but on slide 7, I have links to the book itself. It's open access, you can access it. And there's also the accompanying R package bayesrules. But I'm going to just focus on the accessibility aspects of the book. So the first criteria we decided was the book would be open access. This was our first criteria. But there could be many reasons people actually make their books open access, and we all have our own reasons. For me, one of the reasons was cost of books, actually. And I know that at USAR we have attendees from all over the world, and textbook prices can be different in different countries as well. And we teach, all of the authors, Miles, Alicia, and I, we all teach in the United States context. And they tend to be very costly in the United States. So there is the study that estimates cost of books and supplies for a student at a 4-year university in 2021 to be $1,240 per year. And what is also quite surprising is that about 11% of students indicated that they skipped meals in order to afford books and course materials. Given these facts, having a book that could be costing students a fortune to buy would be a big barrier to accessibility. And also, as a book author, one thing I consider is students are actually part of the book writing process. We did not write this book over one night. Actually, we've used this book as we were writing with our own students before it came to the final version. So students have actually contributed by their comments, finding mistakes, finding typos here and there. So they have been part of the writing process. And actually setting a barrier for them and not having them access the book just because it would be expensive to buy would have been contrary to our accessibility goal. In addition, the website of the book has been accessed from more than 150 countries. So I'm not sure if an actual physical book would have made it to that many countries if it just had made it in print. Shani is actually showing, so we know the book has made it to Argentina at least. That's a good one. Another thing we wanted to do as we were trying to develop our criteria on accessibility, we wanted the book to be accessible to people who are blind and visually impaired. So before I talk about this, I want to talk a little bit about assistive technology. Assistive technology, or sometimes people refer to it as AT, is any form of technology. It could be a software, hardware that helps people with disabilities perform certain activities. Some examples include walking sticks or wheelchairs or screen readers. People could be using AT, assistive technology, permanently or temporarily, but I'm going to mostly talk about screen readers today. A screen reader is an assistive technology that supports blind or visually impaired people in using their computer. And I will give an example of screen reader really quickly. But I have to pause the video immediately.
Navigation.
So this is actually my website in the video. And on the website, I have, on the left side of the website, I have an image of myself, and then I have a navigation bar. What you're going to hear is actually how the screen reader would read my website. And I'm going to pause in between.
Navigation. A headshot of a woman with curly, short, ear-length hair with green eyes and red lipstick. Image.
So you might have heard a description of my headshot, a headshot of a woman with curly, short, ear-length hair with green eyes and red lipstick. And then the screen reader also said image. So the first part of this description that screen reader is reading is actually an alternate text, and it's not necessarily visible to the front-end users, but it is on the back end of the website. And then it said image. Had I not provided this alternate text developing this website, the screen reader would have just read it as image. And I'm going to play again.
List 7 items. Mind Dogucu. Visited. Link. Home. Link. Teaching. Link. Publications. Link. Talks. Link. Workshops. Link. CV. Link.
So it keeps reading. First, it said that it's a navigation bar. Second, it said it read all the links. So the reason I play screen reader in this talk specifically is because I actually tried I'm a sighted person, and I started using a screen reader very late in my career. And I thought that was actually surprising that we don't actually teach our students, or we don't necessarily use screen readers and are not necessarily exposed to it. So I wanted to actually play it at this conference in case there are people who've never heard a screen reader before. So the alternate text that I have mentioned about my photo, and this we might have heard the screen reader read, is actually, it describes contents of an image, and it's usually used in HTML pages. And screen readers cannot read images, but can read alternate text. And alternate text has to be provided. It cannot necessarily appear magically on the website. When we started writing Bayes rules, however, we could not use alternate text. This was a big problem, even though we had so many images in our book and we wanted to be screen reader friendly, we could not provide the alternate text. We have tried some couple of other options, like at the beginning, we were actually giving it as commands file, and then we realized this is not going to be a feasible way to provide alternate text. Actually, alternate text has to be accompanied by images. So in North and Summer of 2020, we actually requested from our Markdown team if they can provide alternate text as an option to figures. And then this was granted, and we could make Bayes rules have alternate text in images. So this was our other criteria. In terms of accessibility, another aspect we considered was making math accessible. And to be honest, this is one of the more difficult side of making accessible book, writing an accessible book. So we tried many things to make this happen, and we hope we achieved it. One barrier usually for students learning Bayesian statistics or statistics in general is calculus. So the book actually doesn't have calculus as a prerequisite. We do have calculus in the book, but if somebody were to read the book without having knowledge of calculus, they should be able to pick up Bayesian statistics, the main ideas from the book as well. I know this is a big discussion topic in statistics education, and for many, it's for some educators, it's a no-no. If you don't know calculus, you cannot learn statistics. But at least I would disagree on that. There are parts of statistics that you can learn, but at the same time, calculus is also very important for the learners. I don't mean to disagree with that. So we did keep calculus in the book as well, but it does appear after we actually cover the foundations. So I thought this was a good way for breaking that calculus barrier and making math more accessible. And teaching probability and Bayesian in statistics in general, students actually come to class, or in this case, readers come to the book with their own intuition about probability. And sometimes these intuitions are correct, sometimes they're not correct. So the way we tried to make it accessible was actually checking these intuitions. If they're correct or incorrect, they should be changing ideas, hopefully, as they read the book, but actually acknowledging that we have some beliefs about probability, and we can try to make predictions, try to foresee what could happen under certain conditions under probability, is one way, of one part of learning. And this quizzes also keeps the readers active as they're learning. So we thought they were an important part of the book writing process. And one way to make math accessible was we relied heavily on computing. So if you look at the book, we actually have a lot of our code trying to accompany the mathematical concepts as well. I guess this is easy to say at an R conference. Computing really helps. And the way we do this computing and math concepts is we actually first try with numerical examples and then try to generalize things with Greek letters later. And with computing, like algorithms, for instance, students are expected to generate the calculations once, of course, using R. And then once they're able to do that, they rely on functions that are already built in R. And making math accessible also meant actually making learning fun. Sometimes, like when we open math textbooks, they usually start with things like, what is probability? Bayesian books, what is probability? What's likelihood? But rather than directly starting with that, actually, we wanted to find math in everyday life, like Beyonce's lyric from Satellite, how can we live if we don't change? This was like a better beginning for a book. This is our opening line from chapter 1, actually. And this usually gave students were usually very excited about the book, starting with this. And to be honest, as a teacher, I'm also very excited starting teaching like this as well. And another accessibility point we considered was mistakes as part of the learning process. Usually in math textbooks, at least the ones during my time as a student, things were like, the proof is obvious, as you can see in the proof, and I could not necessarily see that in the proof. Or we leave the proof to the reader, and the reader is unable to do it sometimes. So we actually accepted the fact that, and we teach it this way usually in our classroom too, some concepts may be difficult, and that's okay. And we might make mistakes learning new concepts. And that's part of the learning process. The point is to keep motivated. So there's this quote in the book, for instance, as you read the book and put Bayesian methodology into practice, you will make mistakes, many mistakes. Making and learning from mistakes is simply part of learning. We hope that you persist through the struggle of learning so that you can contribute your unique insights, perspectives, and experiences to the Bayesian community. And I will also put a side note that's not just about the book itself, but this embracing mistakes as part of learning culture and trying to make math accessible, and it's okay making math mistakes in understanding or in calculations, is that in my class, I actually have this concept called good mistakes. Good mistakes are the mistakes that we do that teach us something. We also have some bad mistakes, like simple arithmetic mistakes. They don't usually teach us much, but actually making conceptual mistakes and then realizing them as mistakes and learning from them is a good learning opportunity. And last but not least, we try to make the content accessible by making it connect with students, by finding relevant examples that they can apply. So this comes from mostly from data applications, of course, the data sets we use, which are also in the R package. We try to have diverse set of data sets This includes weather data sets, LGBTQ anti-discrimination laws data set, Spotify data, hotel bookings, penguins. These are just some of the examples, but we tried to alternate examples from chapter to chapter. And the reason for that is if a student, let's say, is not as excited for weather, they can be excited the next chapter, hopefully. But also it shows the diversity, like the usefulness of Bayesian statistics in different contexts as well. Another feature we considered was also avoiding data sets that actually requires so much specialized knowledge, such as sports. Usually not every student knows every sports game rules. So that would become very hard for them to even work with the data. So we tried to avoid such data sets. Also, like medical studies, sometimes they require a lot of specialized knowledge as well. We actually have a long list of accessibility checks for our book. And this checklist is really coming from our GitHub issues. For every chapter, we had a GitHub issue to check our alternate text goods, our examples, data examples relevant to students' life. And we try to read it from different perspectives, but this is quite a long and comprehensive list. So I have just linked it on slide 18. You're welcome to read a preprint and see the full checklist if possible, if interested. So after having written this book, as we were coming to the close end, I've started thinking a lot about how little I knew about this. And I still know very little about accessibility, actually, having taught it even myself. I started thinking a lot about what was going on in our book writing process. And this actually got reflected into some of my teaching. So I was actually especially very interested in understanding what was going on with the R Markdown alternate text support. So I'm showing a timeline of what went on with knitr, which is actually what supports the alternate text now in R Markdown. And so knitr, the initial commit of knitr on GitHub is actually on October 2011. I went all the way back. And it turns out knitr was initially actually called knit, not knitr. And that's when the first commit was made on GitHub. And the first download from CRAN actually is shown in October 2012. But we actually requested alternate text in July 2020. And the feature was available in knitr in January 2021. So as an educator, as I was thinking about this, what could be possibly going on, that we actually have this tool that many people use, and there's an 8-year gap between its first CRAN download and a very useful accessibility feature. And just to give an idea of how many people could possibly be using R Markdown, we don't know the number of users, but sorry, knitr, I didn't mean R Markdown. Between first CRAN download in October 2012 and when I requested the alternate text request, there were more than 22 million CRAN downloads of knitr. Of course, this doesn't mean that there were that many people, but I think it's safe to say globally there were so many users of knitr, and I'm guessing R Markdown too, that this is quite shocking that the accessibility feature, this alternate text feature, would take 8 years to come. So I started thinking a lot about this, like why this would be happening. There could be many reasons. I don't want to speculate. And it's not just R Markdown, but just in general, how accessibility features seem like in other software as an afterthought. So developers create tools with no accessibility support. And this would mean that data scientists create inaccessible products. So all these years, we've been generating R Markdown reports, websites, blogs, all these. And but they have been inaccessible. I mean, it doesn't mean that now that we have the feature, everything is accessible. I don't mean to say that, but at least when there's no tool to make accessible reports, the reports will by design be inaccessible. So there could be many reasons for that, like whether these companies that create tools in general or people who create developers, whether they actually care about accessibility or not, whether they budget for it or not. But as an educator, I love blaming, also as a person, I love blaming myself on everything. I thought also one problem is that curriculum does not teach accessibility. So I wanted to make that change in my own institution. Luckily, around the same time, I came across Teach Access Network. Teach Access Network is exactly trying to change this. Change the fact that developers and designers and students in general are not trained in accessibility, and they want to make sure they close that gap between accessibility and education. I would highly recommend following them if you're interested in any of this. And in this part of the talk, the teaching accessibility, the examples I'm going to share is my collaboration with Juyang So. Juyang is at the University of Illinois Urbana-Champaign, and I've also linked his social media accounts on the slide 25 as well. So I learned a lot about everything I'm presenting here from Alicia, Miles, Juyang. I actually considered even naming this title, Everything I Learned from Alicia, Miles, and Juyang. So even though you're seeing me, this part is totally our collaboration together. So Juyang, sorry, I'm back on slide 25. Juyang and I have basically sat down and tried to think about how can we make this change happen for our students and hopefully for the general data science community. To give an idea about accessibility and curriculum, so in data science education, we have different groups of people who contribute to data science education, including some group in statistics education, and then some group in computer science education, and then we have so many other domain science education. Then we have subfields of like environmental data science education and so on. And we seem to be scattered in different parts of academia and industry and so on. So this, what I'm going to tell you right now, is coming from the computer science education part. Usually I'm in the stats education camp, and something I have learned more recently as I was working on this work. So computer science education group, or the Association for Computing Machinery, has a data science task force, and they have written guidelines, and it's called Computing Competencies for Undergraduate Data Science Curricula. And part of these guidelines actually have a section called Analysis and Presentation. And for those of us who teach data science, especially for those who teach more on the data analysis aspects of data science, this is, I think, very relevant. And they have different parts within analysis and presentation. So as part of foundational considerations, as a knowledge skill, this is what the guidelines state. Accessibility considerations for different groupings of users, including those with special needs. In other words, if we are listening to the computer science education camp, what they're saying is we should be teaching accessibility as part of data science. And I highly agree with that. Also, accessibility can be considered as part of our students' career preparation. So there's this report, Accessible Technology Skills Gap Report by the Partnership on Employment and Accessible Technology. They ask companies about their recruitment processes and all that. So in this report, 84% of industry respondents say it's important or very important to their company to hire developers and designers with accessible technology skills. 60% said it was difficult or very difficult for their organization to find job candidates with accessibility skills. 0% said it was easy or very easy. 41% of companies consider accessibility certification credentials as a differentiator in hiring. And when I present these, usually in my stats education circles, people are like, oh, this is about developers and designers. It's not about data scientists. But I think in our community, we can think of this as we have so many people at the intersection of design and also being a developer. And there's a very thin line, especially in our community, between being a developer and data scientist too. But at the same time, I think in the near future, as accessibility's importance in our field is understood, I think we will also have data on the needs for data scientists with accessibility skills as well. So Jiang and I have come up with this curriculum goal, the overarching goal, that as educators, we have to ensure that the current and the next generation of data scientists provide public-facing outputs. They could be websites, analysis reports that are accessible to everyone. With this curriculum goal in mind, we considered what objectives we could teach. And what I'm sharing you here is our core learning objectives for our introductory courses. So one of the objectives we had was students should get familiar with Americans with Disabilities Act. So Americans with Disabilities Act is a civil rights act in the US that prohibits discrimination against people with disabilities. But for those of us who are teaching in more international contexts, we can also cover United Nations Convention on the Rights of Persons with Disabilities. And if you have your own country-specific acts, those can also be included in your curriculum as well. Another objective we had was students should use at least one assistive technology. And because we're talking a lot about visual accessibility, for our case, a screen reader use was a must for our student. And the last objective we had was students should consider different representations of data. So as you might actually see, the first two goal objectives that I have mentioned are actually general accessibility objectives. They're not necessarily specific to data science, but the last one I'm mentioning is actually domain specific to data science. And I will talk about that very soon. So regarding screen readers, in case anybody is interested in using them, also, this is exactly the instructions we give to our students too. They can use screen readers on Windows and Mac. They already come built-in with built-in screen readers. On Windows, there is the narrator that can be accessed through settings, ease of access, narrator, and then turning on the toggle under use narrator. And on the Mac system, preferences, accessibility, voiceover, enable voiceover. The screen reader I have showed was voiceover from Mac, for instance. So in terms of data representation, we actually teach in our introductory courses, we actually teach data visualization quite often. And one key aspect that can be included in visualizations is colors and their accessibility. So right now I'm showing a scatter plot with build depth and build length on X and Y axes in millimeters. But you might notice few things about this scatter plot. It comes from the famous penguins data sets. So the species of penguins are actually faceted. They're separated. And second, I'm using color to differentiate penguins. But in addition to color, I'm also differentiating them actually through shapes. So color is not the only differentiator in this image. And these are the default ggplot2 colors for this. So as we teach, we use colorblind R package. Colorblind R package has actually CVD grid function. It can take a figure and actually do color blindness simulation. What that means is if you use this function, you're going to get something for this figure, something like this for this figure. So right now we are looking at a grid of 4 plots of the previous plots, and each cell is actually showing a different kind of color blindness simulated. On the upper left corner, we see the anomaly, which actually is the first image, how that would look like to someone that has green color weakness. So these are, all the other ones are green weak, and then the red weak and blue weak, and then we have the desaturated. So students can actually, even if they're not colorblind, they actually get to experience what color blindness would look like, the figure look like. And important aspect point here, sometimes colors get indistinguishable to people who are colorblind. There's a solution to that, and this is exactly what we color in our courses as well. Okabe Ito color palette actually is a colorblind friendly color palette, and palette.colors function in R. When the palette is set to Okabe Ito, gives hex color codes for this color palette. So if students were to use any of these hex codes, the figures should be colorblind friendly. And luckily, colorblind R package actually has a function that directly just uses these colors from the color palette. The function is called scale color, okabe-ito with underscores, and this will actually change the figure directly with the okabe-ito colors. I have included a few resources in the slides for anyone who might be interested in using these. The first one is a colorblindness simulator for anyone who doesn't necessarily use R for everyday work, but use it for a few things. There is a simulator where you can just upload any image and get it colorblind simulated. There's also Okabe-ito paper, the original paper for the universal design, color universal design. And last and not least, there is an easy to bookmark link for bookmarking hex colors for Okabe-ito color palettes. Another way we cover data representation is data verbalization. So the first, we started with data visualization, but visualization is actually only one way of representing data. So we cover also how to verbalize data. And we talked about alternate text, and alternate texts are a great way to verbalize data. So we are looking at the scatter plot right now. On the x-axis, we have speed. On the y-axis, we have dist. And I want also to draw attention to the caption. There's a caption under the plot. I generated these slides with R Markdown also. This is what the figure caption is. Figure caption goes directly under the plot. The speed of cars, miles per hour, and the distances in feet taken to stop. So let me show you also how this code is actually generated on the R Markdown side of things. So I am writing two code chunk options. First, I have fig cap, and then I have fig out. The fig.cap is actually what the figure caption is shown to the user, but fig.out is actually what is on the back end. So if somebody was actually using the slides and was listening to the previous slide, that's what they would have heard being read to them. Regarding representing data with alternate text, there are some recommendations in the community. One of them comes from Data Visualization Society's Amy Sezel. Her Medium post lists 4 main parts of an alternate text. One is chart type, second one is type of data, and reason for including the chart. And then also link to data or source, not in alternate text, but in main text. And if you read Amy Sezel's post, it generally actually talks about figures, let's say in a journal post with just a figure that comes alongside the text. So there is the text that's also actually helping the reader understand the plot as well. However, we have some data science scenarios, we only have the plot, not necessarily a text that accompanies it. So in such cases, we also have to write alternate text. One example is Tidy Tuesday. For those of you who may or may not know, Tidy Tuesday is a community event. Every Tuesday, there is a data set released and people get to work on however they want to work on with that data. And many members of the community actually make visualizations. And it turns out, based on the study of Canelon and Hare, many people don't actually use alternate text when they are sharing their Tidy Tuesday visualizations online in social media. And they actually also evaluated those who actually provided alternate text based on these 4 criteria. Description conveys meaning in the data, variables included on the axes, scale described within the description, and type of plot is described. So we can also consider these as criteria, good criteria for writing alternate text. So both of these guidelines are, I think, very informative and good to share with learners in general. In addition to writing the alternate text from scratch, we also have automated tools for alternate text. So I'm showing a bar plot right now. On the x-axis, we have transmission of a car, and then the bars represent automatic or manual transmission. And I'm going to show you now an automated alternate text for this bar plot. So the function comes from Braille R package, and the function name is VI. And if you give the object the plots for the function, it's going to create some alternate text for it. So I'm going to read some of this. This is an untitled chart with no subtitle or caption. It says x-axis transmission with labels automatic and manual. It says y-axis count with labels 0, 5, 10, 15. I'm not going to read the rest, but you get the idea that this is really an automatically generated alternate text. It gives like very numerical details. So this is actually a great tool for basic plots and can be used, but at the same time, it doesn't really convey like why, but what does it even say? Like, why would we include that transmission and automatic in the visual? Like, what are we trying to get to by saying it? Are we saying one is higher than the lower? So it actually creates things that may be not necessary. And another drawback is that not every type of plot is actually supported by the VI function. For instance, in our Bayesian book, we have plots called trace plots, and they're actually very hard. They would be very difficult to automate within a tool. And going back to alternate texts are underutilized in the data science community. I mentioned Canelon and Harris' study. They found over 3 years of this day, there were 7,136 database tweets, and only about 3% of them had alternate text. They do mention also in their talk briefly that the numbers seem to be promising over time, but still, I think we have a lot to learn together as a community in this aspect. In addition to verbalizing data, another tool we teach students is thinking of data as sound. So data can be represented with sound. Some options there are multiple packages actually that do this, but the one we teach is the Sonify package. On the left, I have code for a vector, creating a vector of x and y, and both of them go through 1 through 10. And when we look at the scatter plot, and then use to sonify the scatter plot, oops, I'm so sorry. I'm on slide 44 for anyone following. So we can actually hear this plot getting higher and higher pitch as each point changes. So this is another way to represent the scatter plot via sound. Last but not least, another way we can have data represented is through tactualization. Data tactualization refers to making data visualization in a form that it can be touchable. So I'm going to show a video. Actually, this is Juyang's video that I also use with my students. So he's going to print graphs on swell paper. He's placing the paper in the paper feed. And then he's going to go ahead and print it by checking the fit of the paper. And it's now printed. And he's going to swell the ink using the swell heat machine. And he got the printed paper now. And he's touching it, and he can actually feel the paper and the box plot and the whiskers and the borders of the paper. So this is a tactile box plot that we get see a close up of at the end of the video. So before I was teaching this and using Jiyoung's video, I asked Jiyong, can I tell my students that this is a 3D plot? And he said that just tell them it's a 2.5D plot. Another package in R that's useful for data textualization is actually Jiyoung's own package, Tactile R. What this package does is it takes a plot. In this case, we are taking a histogram of air quality and ozone. But before the histogram, on the left, we have a code that actually begins a braille and ends a braille. And this code is going to create a file that is called tactile PDF, and it can be printed with a special paper using braille fonts. And on the right, we see what that PDF created would look like. We see that the histogram actually has axes with braille printed. So this is what I have said in this part of the talk as different representations of data. It's just one way of introducing accessibility to students, but it's not meant to be a complete introduction to accessibility. So Jiyong taught this in his introductory data science class. I taught it in my seminar in data science course. And there are many other ways accessibility can come up in can be incorporated in the data science curriculum. One example is, like, for instance, I was teaching this course where students were giving video presentations. I had to teach them how to write closed captions. So it doesn't even have to be a data context. But for those of us who teach Shiny, for instance, or just in general dashboard development, accessibility is very important. So I do cover that in one of my courses very briefly, and actually incorporating and introducing students to web content accessibility guidelines, WCAG, can be important. What I have shown in this talk is just one example, and it's definitely not a comprehensive example. There are people who teach a full course on accessibility. This is just one way to get students to thinking about accessibility in data science. So based on this curriculum development experiences and teaching experiences, I wanted to make some recommendations for the community, both for teaching accessibly and also for teaching accessibility. So we all know the saying, a picture is worth 1,000 words. I want to tweak that a little bit and say that an alternate text is actually worth 1,000 pictures, because alternate text is accessible to everyone, but a picture is not necessarily accessible to everyone. Fixing a typo is a good full pull request. This is also something we commonly say for those of us who teach Git and GitHub. But I want to change that a little bit and say fixing a typo and writing alternate text are good pull requests. Our students should feel, or newcomers to, for new learners of pull requests, if they're able to see the images, that writing alternate text is a good way for them to actually contribute to open source as well. And in terms of teaching accessibly, I know that many of us, including myself, we learn so much from our community. But in learning environments, we have this thing called disclosure. And disclosure can work differently in different countries and different institutions even. So, for instance, in my institution, if a student has a disability, they first have to disclose this to the disability services, who then discloses it to me as a professor. But some universities actually expect that disclosure from student to professor directly and so on. But when we are talking about public events, for instance, so much of our events are at meetup levels, for instance, or conferences or workshops. In all these things, expecting disclosure from the person who needs accommodations can be a little bit intimidating. And as a person who has invited many people to conferences, I know that people with disabilities at this point are so excluded from our events that they actually don't even have the motivation to check for accessibility sometimes. So this disclosure should fall on people who organize events. They should be the ones to tell what they are providing, and we should be providing the accommodations, of course, but there are some common accommodations like screen readers. This information should be available on our event websites. And also even simple things like if the event venue for meetups, is it wheelchair accessible? We should not necessarily wait for people to ask us, is it wheelchair accessible or is it like this? And I know that globally there are different regulations about these, but I think this responsibility falls on the event organizers. And I wanted to say a few things about accessibility. Accessibility sometimes can be seen as charity work, which is, in my opinion, very wrong. So accessibility should not fall on volunteers in the sense that people who basically are running events or organizing events, or corporations who are hiring people or benefiting from the open science community, they should not just assume somebody who's an accessibility expert will give their time for free to them. That should not be the case. Actually, experts on accessibility, that's a professional career, and these people should not be expected to donate their time. And the reason I'm actually mentioning this at a keynote is that I do see this quite often in social media, that this is expected. That's not okay. But at the same time, I know that in our community, we actually have a lot of work that is based on volunteering, like meetups, many meetups, our user groups, our ladies. This actually is volunteer work for all of us. It's not necessarily a professional paid work. So in such cases, I think it would also be good to consider volunteers specifically for accessibility, which I think is not usually considered. We do have like marketing volunteers, we have events, venue organizers, but we don't usually have accessibility volunteers. I think this is something extremely important for us to consider in our local communities, especially. In terms of teaching accessibility, I think that accessibility should be taught at undergraduate, graduate, and equivalent practitioner trainings. For instance, I was teaching an R course in graduate level, and especially teaching in a statistics program, accessibility might seem a little bit out of the statistics curriculum to someone who is actually looking at the curriculum for the first time from an accessibility perspective. But I would actually disagree, because if we don't teach accessibility at these levels, students will not learn it. Like they will not necessarily be on Twitter or LinkedIn trying to find this. So we have to explicitly add it to the curricula. But at the same time, for many of us, we may not necessarily be having schooling, or we may have had schooling way in the past. So I think we should be mindful when we are developing new our trainings. Anyone who has equivalent practitioner training, like we should include them. So I think the natural place, like I said, if you're teaching a data visualization training, different representations of data is a topic to be included in such a training. And accessibility can be taught as part of language-specific and language-agnostic trainings. So I have mentioned that I have taught accessibility in my seminar in data science, which is a language-agnostic course. I did provide R examples, but I have also provided examples from other courses too. I know this might be a little bit strange to say it, but I love SAS and their website on accessibility. That's a great example to use, for instance. But we should not think of accessibility training in data science as just an art topic. Like, accessibility is important no matter what kind of language we're using, what kind of topic we're teaching. That being said, accessibility should be taught in a way that learners can apply their learning in non-data science context too. So when I teach a data science accessibility, when I teach my students alternate text, they should, my hope and my goal is to have them also take this alternate text knowledge and maybe include it also in their presentations in an anthropology class. So they should not necessarily be thinking about accessibility as a data science context. It's actually not necessarily domain specific. However, we should teach them domain specific knowledge, like how to do it for a data visualization. Students should be assessed on and held accountable for their accessibility practices. And this recommendation actually comes from a personal place. Way back in the day, in early 21st century, when I was an undergraduate student, I was actually taught alternate text, for instance. And but it was just mentioned briefly. And we know that for learning to happen, students need repetition. They need to be assessed. They need to make it into a habit. And unfortunately, just covering it once and leaving it there is not going to get them to use it. So one way to do this is actually incorporating into rubrics. So for my homework, assignments, projects, and so on, I would explicitly write down criteria. Are alternate texts included? Do alternate texts meet the criteria for guidelines criteria? And so on. I think this gets students thinking more about including it all the time. And I have had students also include them after that without any prompts as well. And I will finish my talk with one reminder. Accessibility is actually for everyone. So during this talk, you might have seen human captioning. So we are at a global conference and not everyone is at a reasonable time zone. So there might have been a person actually trying to listen to this without any sound, but they might have relied on human captioning, and they don't necessarily have to be deaf or hard of hearing. Similarly, we've talked about alternate text. Alternate text might just seem for people who use screen readers, but that's not the case. Actually, alternate text also helps search engines find images. For instance, I shared an image with knitart timeline. There is no way that would make the search engines without alternate text. There's, of course, some image recognition involved as well, but still, alternate text actually makes us have images be more searchable. In addition, this conference is virtual. That actually helps us access it from different parts of the world as well. So that is all to say, accessibility is for all of us. Thank you.
Okay, thank you so much, Mine. was an amazing talk. We have a lot of questions. I'm going to group them, and so trying to do a general question to answer several. I'm going to take the questions about. Can you talk more about how you will test the accessibility principles or your note slide activity? Not color, that is very well known and studied, more about testing for a visually impaired audience. For example, where a specific alt text is informative or not. People also ask about a good alternative text for plot or for maps. So I think this question can group them.
Mm-hmm. Yes, I think this is a very good question. One thing I want to mention about I'll first talk about alternate text. So for writing alternate text, I think it's very difficult in general, especially if we are beginning, and I'm also like beginner alternate text writer. I'm not necessarily an expert. One thing that really helps me is asking somebody else who has not seen the image what they think of the image. That usually helps me write it. That usually is a family member, like my partner. That I find helpful. And also, we should not think of alternate text as something as a static. Like, actually, you can improve your alternate text. So you can write it, and then you realize that this is not a good alternate text, so you can keep adding to it. That's another thing. Just like we improve our teaching materials from one semester to the next. So when we are reviewing them, they are reviewable. And I do, like when I'm writing it, I also like those guidelines I have shared from Amy Sazal and Sylvia Canelon and Liz Harris resources. I do use them as check marks as well. Like, have I done this? Have I done that? And so on. Even like when I was preparing my user talks, like one of the things they mentioned in their talk is axes actually being mentioned with units. And I had forgotten to put my units. And immediately, because I use that as a checklist, I put my units. And for a sighted person, like units, even though it was somewhere in the text in my slides, but I remember, no, it doesn't have to be, it has to be in alternate text as well. So using these as checklists, and the thing I mentioned about the preference for other accessibility features, like we have literally had a checklist, like have we done this for our book? Have we done that for our book? And so on. So each of these are easy. One accessibility thing I think is very difficult, that is hard to check, that is in the preprint, and I did not mention, trying to read something like a teaching material from a different perspective. Like we were all US educators, but we were trying to make it accessible to non-US learners as non-US based learners. So trying to read something and think, oh, this example may not make sense because it's not obvious. One example is like we had something about US elections, which is like very US specific. We had to write additional text for that. So things like that are difficult to catch, but at the same time, with a checklist is a little bit easier.
Oh, thank you, Mine. I'm going to read one more questions, and then I'm going to finish. If you want to, you can answer typing your answers on the questions. Because we are already over time. So the last question is, people wants to know about the tones that we hear when you switch the slide, how this help to accessibility, and how do you do that on our Markdown?
Great question. So if there is anyone who's been following my talk from screen reader, for people who are sighted, they were able to see my slides. But possibly if somebody was using screen reader, I don't know how they would be attending. Maybe they didn't care at all, but they could open my slides. So every time I switch slides, they would be switching with me, and all the figures at alternate text. So they would simultaneously be listening to alternate text and possibly checking the text on the slides. If they wanted to do that, they could. And the function, so my slides are actually open access, like on the on my GitHub. And I don't remember the name of the function, but it comes from the sharing an extra package. So
Okay.
somebody has
we can watch on the code. We can go to the repo and watch on the code.
Yeah.
Okay, thank you one more time, Mina. It was an amazing talk. Thank you so much for talking about this and to share this with us. And now I'm going to invite Matt, our chair, to close the conference.
Hello, this is Matt Shotwell. Thank you, Mine. It was a lovely and educational talk. Really appreciate you taking time to present to us. I'd like to make a few announcements and closing comments. And I'd like to start with our poster awards. And many of you may not have known that we were doing this, but each poster was scored by at least 2 members of the USAR 2022 program committee, and there were 5 facets to the scoring criteria. We judged posters based on quality of the poster abstract, outline, introduction or summary, the organization and clarity, the quality of the content, the quality of graphics and visualizations, and the impact and added value. One of our program committee members, Nicole Swartwood, put together a very nice poster review rubric to help us do this, and also was able to normalize the scores to make this a most fair comparison. So 5 winners were selected based on the average score for each poster, adjusted for reviewer bias, and the winners will receive a free book from the CRC Press book catalog, which includes 64 titles in the R series that focuses on applications and methods in R. So the winners are, the first winner is Abdulaziz Narusadad and Akbar Rizki for a poster titled Twitter Bot using RVest, RTweet, and GitHub Action. The second winner is Maciej Nazinski. I tried hard. I even looked up how to pronounce it. I hope I did it justice. With poster titled Conscious R Packages Maintenance. Our third winner is Kara Thompson with poster titled Level Up Your Labels, Tips and Tricks for Annotating Plots. Our fourth winner is Conrad Oberwimmer with poster titled Automation and Mass Production of Charts with SVG Tools. And our final winner is Peter Fortunato with poster titled How R helps to evaluate the safety performance of a metropolitan highway network. So thank you very much. And one of our organizing committee members will connect with you, with these presenters, after the conference to share the award details. And I'd like to remind everyone that the posters are still available to conference participants in the poster area. And I encourage you to go back and check these out if you haven't seen them. So now I'd also like to thank again our conference sponsors, including our platinum sponsor, Absalon, our gold sponsors, our consortium, RStudio, and Oracle, our silver sponsor, Microsoft, our bronze sponsors, Google and MemVerge, and our small business sponsors, OpenFX, Jumping Rivers, RBloggers, and Syncra. I'd also like to acknowledge some special supporters of the conference who were not sponsors but contributed nonetheless. The first is CRC Press, of course. They provided prizes for the poster awards. I'd like to thank the Chan Zuckerberg Initiative. They provided support for both the live captioning and also support for post-conference captioning and work that we're going to do to make the materials that we've recorded publicly available. I'd also like to thank the Department of Biostatistics at Vanderbilt University Medical Center, which is the home institution for myself and for several other members of the organizing committee. Our department provided administrative support for the conference and also effort support for 2 members of the organizing committee. I'd also like to thank the organizing committee itself. As many of you may know, planning a conference like USAR is an enormous effort, and this year's organizing committee are mostly volunteers and have been working for nearly a year to put this conference together. And of course, we all do it because you know, we've all benefited from R, and we just want to give back something in the way we know, the way we know how. So our committee members this year were Jenna Altstadt, Stephen Balogan, Yanni Bellini Sabine, as you know, Peg Duthie. Peg is our social media guru, and she's responsible for all the great tweeting and announcements on LinkedIn. Really appreciative of her work. Ben French, Sean Garbett helped a lot with the website. Amber Hackstadt did a lot of work with sponsors and a lot of work you didn't notice, but she also volunteered to be a backup chair in case any of our chairs had other responsibilities to attend to. Omer Khan chaired our committee, I'm blanking on the word now, but the Code of Conduct, sorry, the Code, yes, thank you, the Code of Conduct Committee Chair. Andrea Vargas Monteiro, Tom Stewart, Nicole Swartwood organized a lot of the poster session and of course the poster award rubric, and Aditi Ipadya. I'd also like to thank the program committee who did a lot of work helping to organize the program, review abstracts. There are a lot, it's a bigger committee. Louis Darcy Verde Ariogida, sorry, I hope I pronounced that correctly. Louis Aslett, Beth Atkinson, Jesse Blocker, Ben French, Lucy D'Agostino McGowan, Tal Galitti. Tal is also a small bit, he leads the RBloggers website. He's also a small business sponsor for the conference. Bob Mention, Dorothy Hug-Peter, Riva Quiroga, Jermaine Rosati, Mina Satinkia Rundle, Yanni, Bruno San, Jesse Spencer Smith, Tom Stewart, and Nicole Swartwood. I didn't know Tom was going to put this in here until just a few minutes ago, but Tom, if you want to take over.
Great, thanks, Matt. We all know that organizing USAR is a monumental task, especially during a pandemic. And I've seen firsthand the challenges that the chairs of our organizing committee and the program committee have confronted as they prepared for this conference, which is definitely large and very complex. In short, Janina, our program chair, and Matt, our organizing chair, have been superb. and they are deserving of special recognition for their hard work and contributions to this conference. So, if you could participate with us a little bit here, I'm going to invite each of you to like and retweet a recent post by the USAR Conference Twitter handle, thanking both Janina and Matt for their service to the larger R community. I'm also pleased to announce that the leadership of the Department of Biostatistics at Vanderbilt will award both Janina and Matt an honorarium. It does not match the hours of work that they've put into this conference. It's just a small token of our appreciation and thanks. And with that, Matt, Janina, thank you so much for all that you've done to put this conference together. Matt, back to you.
Thanks, Tom, and thanks, Yanni. Yanni's been amazing throughout this whole planning effort, and an amazing resource for all of us, having participated in last year's conference as well. Okay, I just wanted to give a few numbers about participants. We had a little over 1,200 participants register this year, about a quarter from Europe, a little bit more from North America, and another quarter from Asia, South America, Africa, and the Pacific, Australia, and Oceania. And lastly, I'd like to thank, I have a couple of more announcements here. Let's see. Although the conference officially ends today, the Our Contribution Working Group has organized a global bug barbecue event. We've mentioned this a few times previously, and it begins in just a few hours from now for participants in Asia and the Pacific regions, and it runs through Friday morning for participants in Europe, Middle East, and Africa, and Friday afternoon for participants in the Americas. Additional details can be found on the conference website program overview page. I'd also like to announce that at the moment there is no team in place to host USAR for next year. The R Foundation are considering their options in this regard, including the possibility of a one-year hiatus. However, if any group is interested in organizing the conference in 2023 or 2024, the R Foundation Conference Committee welcome informal inquiries to their address, conferences@rproject.org. And finally, I'd like to thank all of the speakers, presenters, and session chairs, and all of the other participants for their contribution to USAR 22. And I hope to see all of you at a future USAR. And with that, I will close the conference, and I wish all of you a lovely rest of your Thursday.